Yeah, hello and welcome to today's GFG problem. The day hope you're doing well. So let's say today's problem, non-overlapping intervals. Okay, so what the problem is saying is we'll be given a 2D array intervals of representing intervals where intervals of I start end. You want to return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. So again, we have been given an interval problem. So you know this is a start. This is an interval. Okay, and this is the start of an interval, end of an interval, start of an interval, end of an interval. Okay. Now what the problem is saying is we want to remove the minimum number of intervals so that the remaining intervals become non-overlapping. So first of all, let's jot this down. Okay, for example, here this interval starts at 5 and ends at 10, right? 5 and 10. Then this particular interval, it starts at what? 45, 40 to 45, right? 40 to 45, right? And then this particular interval starts at 18, 18, right? We can say let's document it here, 18 to 35. Okay, 18 to 35. Then this particular starts at 8. Let's write it here. 8 to 17. Right? 8 to 17. And this particular interval starts at let's document it here, 1 to 2. Right? 1 to 2. Okay. So So these are the intervals I've documented. Now, if you see which is the overlapping one, right? Which is the overlapping interval, basically. So if you check this particular interval, it is overlapping with this particular interval, right? Because it is less than, or it is starting before the previous interval has been ended, right? Before the previous interval has been ended. So if we just remove this, so now if we just remove this, right, this particular interval, right? So if you see now, if you check whether the remaining intervals are non-overlapping or not. So if you check, yes, this is non-overlapping because this is starting after this is finished, right? Right? Then this particular interval is also non-overlapping because this is starting after the previous interval has been ended. And similarly, for this last interval is also non-overlapping because this is getting started after this particular previous interval has been ended. Okay, so just by removing one interval, okay, we have the intervals which are non-overlapping. So we'll return the count of the minimum removed overlapping intervals, which was one in this case. Okay, so I hope you've got the problem. Now, how can we solve this problem? So now by now you must have known. I mean, this is I think third or fourth into problem given by Geeks for Geeks, right? So what you need to do is always there's just like two approaches. Either you have to sort by start time or you have to sort by end time. So you go through the examples. Okay, just have the two sorting mechanism, right? So whichever, like for example, if you sort by start time, right, and you go through the examples, and if your problem is getting solved, then yes, sorting by start time is the right approach. If it is not working, then you need to check by sorting by end time. Okay, and solve the problem, and look at the problems whether the problem is getting solved. Okay, look at the examples whether the problem is getting solved. So let's see. So let's try. So for example, for this particular problem, right, let's sort by n times. Okay, let's sort by n times. So how it will look like? So for example, this sort by n time, okay, in ascending order. So 1 2 will come first, then will come this one, right, 5 10, 5 10. Then which is the minimum n time after this particular, it is 8 17, 8 17. Then comes 1835, 1835, and then comes 40 45, 40 and 45, right? So these are the intervals which you have sorted by n times in ascending order. Okay. Now what we're going to check is so we will consider this as n first. Okay. Let's say for the first interval we'll have a variable. Okay, and we'll assign the end time of the first interval to this end. Okay, which is 2. Okay. Now what we're going to do, we are going to start iterating from this particular interval. Okay, we are going to check is the start time is the start time, okay, less than the previous end time. Is this particular interval starting before the previous interval has been ended? No, right? What we're going to check here is the start time less than the end, right? No, it is not the case. That means it is not an overlap, right? It is not an overlap. So simply what we're going to do, we will update our end with this particular end. Okay, just be with me, you'll understand. So now our end is 10, right? Then we will come to the next interval. Now we're going to check, is the start time of the current interval is less than n time of the previous interval, which is what? 10, right? Yes, definitely. Yes, this condition matches. This condition matches. That means we can say this interval is getting overlapped with this particular interval, right? 8 and 10, right? So, so this interval. So we will have a count variable, count equal to, we'll say 1. Okay. Okay. Then let's go ahead. We will update our end as well. This time I think, yeah, this time it's not needed. So we'll keep our end as is. We'll keep our end as is. Now we're going to go ahead and we're going to check. We're going to check because since we want to eliminate this particular interval, right? And hence we are not going to update. We are not going to update our end with this end. Okay, our end with this end. That is why we are keeping this end unchanged. Okay, now we're going to check here. Is 18, right? The start time. Is it less than end time, which is 10? No, it is not. That means it is not an overlap. Okay, and we'll also update our end time with the end time of the current interval, which is 35. Now we'll again check here. Is the start time 40 less than end time, which is 35? No, it is not. That means it is not an overlap. So we had only one interval which was getting overlapped. Okay. Okay. So I hope you have got the solution. This is intuition. Okay. So now just go, let's go to the code and do let's do the Java code first, followed by C++. Okay. Just one request before going to the code. I'll request you to please subscribe to the channel, like the video. Okay. So let's sort according to the end time. Address dot sort. Right. Then we have our intervals, then a comma b, and a of 1 we want to sort, which is the end time, right? In ascending order. Okay, so we have sorted the intervals according to the end time in ascending order. Now we'll have our end variable int end equal to intervals of 0 of 1. Okay, okay, so we have taken the first interval's end time and assigned to the end variable. Now we are going to iterate from the second interval, right? Intervals dot length plus I. Now we're going to check here is intervals of I of 0, the start time, is it less than the previous end time? If it is, that means that is an overlap. Okay, we'll have our count variable as well. Count equal to 0 plus count. Okay, plus count. Okay, else if it is not an overlap, just update the end variable. Okay, with the current interval's end time. I of 1, we'll say. And that's it. Just return count. Let's compile it. So time complexity again, it is going to be O of n log n because we are sorting, right? Let's submit. Okay, the test cases are passed. Thanks for watching. Please don't forget to subscribe to the channel, like the video. Let's quickly see the C++ code as well. Here's the C++ code. Here we are sorting according to the end time in ascending order. Then I've already explained this. It's the same in Java. Okay, I'll attach the code in the in description. Okay, thanks for watching. Don't forget to subscribe to the channel, like the video. Have a happy, healthy, wealthy, and a great day. Thank you so much.